All right, so am I audible? Hello, are we live on this? Hello, 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 hello. I think we are live. Hello, hi Karan. Let's just wait for like 2 minutes. Karan, am I audible, right? The video is there and I'm audible, right? Can you just confirm quickly? Great, thank you so much, Karan. Okay, so I think some people will join. Let's wait for like 2 minutes. I started a bit early. We'll start from 10:30. Hi Tejas. I hope there is not a lot of background noise, right? And everything is fine. All right, great. So should we start, guys? Anybody in the chat, please confirm. Should we begin? Okay, so let us begin. Uh, Hello, everyone. My name is Viraj, and today we'll have our Leetcode Biweekly Contest discussion. We'll be taking all the 4 problems today. So before I go further, I would want you to know about something that we do at TLE and we have launched that is called TLE self-paced CP courses. Basically, if you have been following TLE so far and if you know about a journey, all the best lectures that we have taken so far, all the best content that we have taken so far, we have brought everything together for you in a self-paced course. Self-paced is self-explanatory over here. And as usual, they are bifurcated in 4 levels. And this brings us all, this gives you a start in your CP journey, right from level 1 to 4. All the topics, all the features, syllabus, prerequisites that you have, the general FAQs and the testimonials of other students we have had so far is there on the website for you to explore. And we have a very limited offer that's running for you for an early bird discount in this scenario, that is 20%. And if you're an alumni, you have a 30% discount. And additional bundling, if is done for 2 consecutive levels or 2 consecutive courses at a time, you get additional off there. So overall, this is a steal grab. The price is lower than our normal sessions, normal lectures that we used to happen back in TLE 11, 12, and before. And yeah, this is all about self-paced. So do check this out and make sure you become part of this journey. I can assure you this is going to definitely improve your CP journey overall. And for all those who want to explore for the first time, this is going to be a great place to start. Okay, so let us quickly begin. I have 4 problems with me. I'll be beginning with the first problem. So Ketan, I think today's PCD should have happened, but I think there was, you can say, a clash probably there due to some reasons. So when one day has a lot of different contests, this normally happens. But no worries. We'll try that. We can bring you the post-contest discussion probably tomorrow. That is one day later, Ketan. So do check out for that part. Okay. Let's come to Leetcode as of now. Did you guys give Leetcode contest today bi-weekly? How do you felt the problems were, and how do you think this went for you? Anybody who's watching the video after this session can comment down in the chat and tell me what is your overall idea on this bi-weekly session and this bi-weekly contest. Should we start, guys? Great. Thank you so much, Ayush. Thank you. Let's begin. Okay. So let's begin with the first problem. Find the most common response. Now, this has a medium tag problem, although I felt this is on the easier side. It has all about implementation. So what I'll try to do in all these 4 problems is give you a lot of intuitions and give you a lot of topics which are sort of the prerequisites for a problem, so that tomorrow when you actually try to solve these problems or similar problems, you can prepare these topics first, and then maybe your Leetcode contest goes better tomorrow. So this problem itself is going to implement just simple implementation and brute idea, brute approach. And if you know a little bit about maps and sets or something like that, then this problem is fine. So let's quickly read. You are given a 2D string array responses where each response I is an array of strings representing survey responses from the ith day. Return the most common response across all days from removing duplicate responses within each responses of I. If there is a tie, then return the lexicographically smallest response. String A is lexicographically smaller than string B if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet than in the corresponding letter in B. If the first min of A.length, B.length characters do not differ, then the shorter string is the lexicographically smaller one. So they're giving you a neat definition over here of what is lexicographically string. And otherwise, let's quickly understand this problem. So they are saying that they will give you an array. Okay. And this array is basically a 2D array. So you can say that you have something that looks like this. This is a 2D array, right? So on, let's say this has 3 arrays inside this. And then each array itself, let's say I pick up this array has strings in it. So let's say there are 3 strings, 4, 5 strings, whatever you can say. There are strings in this. And then I have to, first of all, remove the duplicate responses or duplicate strings within a single array. And then after that, I have to find the most common response across all such arrays or all such days in this scenario. So I'll give you an example over here. Let's say good, okay, good, okay. This is one particular array. Now in this, it's very obvious that good and okay basically are coming 2 times, right? So if I tell you have to remove the duplicates in this array, if I tell you have to remove the duplicates in this array, what do you say? You say that, okay, the good and the okay word will only remain, and this good and this okay will go away because duplicates have to go away. Okay, so in the first array, now only good and okay remain. Now after this, I come to the second array. In this, I can see that, okay, bad and good come 1 time, but okay is coming 3 times. So I'll remove the duplicate occurrences of okay, and I have okay, bad, good. Then I have a single array having good and a single array having bad. So finally, I have removed the duplicacy and the responses look like this. So I hope this part should be clear. And after this has happened, now I want to figure out what are the occurrences of each and every string. So I can say that in this particular 2D array, overall, good is coming 3 times. So I'll count this. Okay, good comes 3 times. Okay is coming 2 times. Bad is coming 2 times. Now the most common guy is, of course, good. So I'll say, let me print good. It has the highest frequency. Had we taken example number 2, in which after doing the duplicacy removal, you can say that I'll be left with good and okay, okay and bad, bad and not sure, and great and good. After this, you can say that bad, good, and okay, all three of them rather have 2 times of occurrence. Now, there is no guy who is winning over here. So how do you tackle that scenario? It's very easy. They have said if there is a tie, then you return the lexicographically smallest response. Now, I'll pose a simple question to you guys. Do you guys understand what is lexicographically smallest, or lexicographically, this word in general? Have you guys heard of this previously? Lexicographically. Have you heard this? Yes, Ashutosh has heard this. So for all the beginners who are seeing this video, and maybe we'll see this after, I'll give you a very small definition on lexicographically. It's very easy to remember that way. This is a very strong word. Replace this word with how a dictionary looks like. You can say dictionary looks like. Everybody has seen a dictionary, right? Correct? So when I say that there is a word A, okay, there is a word A and there is a word B, and lexicographically the word A is lesser than the word B, then basically I want to say that in a dictionary, A must be coming before B. Okay, this is what defines to be in a dictionary. And all those who you think can read a dictionary it's very easy to then recognize that whether A as a string is lesser than B or not. Okay, so over here, A is lesser than B if the first letter from the start is different and is lesser than A, lesser in A rather. So if let's say the string A looks like the characters A1, A2, A3, so on, and the string B looks like the characters B1, B2, B3, and so on, then let's say the first place where the letters did not match is this location. Let's say the second location is the place where the letters did not match, and everything before that was matching. So if A2 is less than B2 as a letter, then I know that A is less than B. And I know A would be coming before B in dictionary also. So this checks out. Okay. This is the idea of lexicographically. Now, as I come back to the second example, if I see that bad, good, and okay all have 2 occurrences, I cannot select the guy who is like I have a tie basically over here. So I know I want to select bad because bad is lexicographically smaller than good and okay. Why? Because this first letter B over here is actually lesser than G and lesser than O. Very obvious. So I know bad is lexicographically smaller. Is the cases clear? Is the question clear, guys? Should we move on quickly to the solution? Solution is very, very simple. It's like basic implementation. Whatever we just understood in the examples, this is something that we want to implement. And how do we implement this out? If I look at the constraints, basically, I have fair margin over here. If I use some sort of a brute idea where I actually try to simulate all this in picture, I think I'll be good to go. The length of the 2D array is not very large. Inside that, individually, every array is also not very large. And the string itself is very small. Any string that you pick up, it's less than 10 size. So maybe I can run a very simple pseudo idea. I'll give you the pseudo idea, guys. I'll say that, okay, let's actually let's actually create a map. Okay, why a map? Because we want to maintain frequency, very obvious. So I can say that I have a, let's say, map, and this map is of what type? This map, you can say map, is of the string, comma, int type. Because I want to store the frequency of a string against an integer. Okay, great. Now, what I can do, I can go in the responses. So I'll iterate in the responses. When I iterate in the responses, I actually come to every array singular time. Now, when I'm inside this loop, I am inside one particular array. So that's the first array, second array, third array, fourth array, and so on. Now I can go on the first array and I can go to that string. Basically, this is how you iterate in a 2D grid. You can imagine that way. Simple 2D array iteration. But before you do that, you want to remove duplicacy. Now, guys, can you tell me what is the best way to check you can remove duplicacy or not? Can you think of any data structure quickly in the chat which removes duplicacy for me? Can I take a set, guys? Correct, Ashutosh. So I can say that let's create a set for myself. Now I'm not concerned with the order in this set, so I can maybe create an unordered set of the type string. Let's call this S. And then what I can do is I can iterate again in that 1D array. So let's say over here the array was res right now. So I'll iterate in res, and every time I iterate in res, come to each and every string, I'll insert in this set this particular string. So let's say that string is let's say res of I, something like that. We'll see the implementation part. That's not a big deal. And after you've done this, you know that in your unordered set, duplicacy has gone away. So one array's duplicacy is removed. Now the non-duplicate occurrences are there in the set. So all you want to do is iterate in this set and place all those occurrences in the map. So I can say, let's iterate in the set and let's place everything in map. So let's say map of IT something equals to plus plus. Over. And after this, all you want to do is come out of this for loop and figure out the guy who has the highest frequency. And if all of them have very high frequency, all of them in the highest frequency, you have to figure out the guy which is the lexicography smallest guy. I hope the implementation part is clear. Yes. Let's look at the code part now. So as I've explained, very simple thing. I have created a map, string and int. Now I'll go in the responses. So I use for auto res in responses. This is again, any beginner who is watching this, it's a method of how you can iterate using iterators based method in strings, in arrays or vectors quickly. So I have res, that is one Venn vector that I'm iterating to. Then the unordered set, auto I in res. So I'm inside the vector now, a 1D vector now. I insert that in the set. And then when I go in that set back, that is auto I in S again, M of I plus plus. So I'm basically able to increment the frequency. Now, when I come out, I can say that what is frequency that I want to find? I want to find the highest frequency. So let's maintain a frequency variable, which is -1. It's the lowest right now. I have a string. That's the answer. I'll go in the for loop. And then if I find that the it.second frequency is it.second, that is the current frequency is greater than the frequency variable, then I'll make freq equals to it.second and answer becomes it.first. And then I come out of this for loop. I know I have for short saved the guy which has the highest frequency. And also, by the way, I have saved the guy which has the lexicographically smallest if it was a tie. Now, how have I done this? Any ideas, guys? I'm not keeping any other check, but it's still going to work, by the way. If I return answer, I know it's working. Do you know why? So map in general, the thing that I've used over here, map in general is going to sort all the strings on the basis of keys, right? This is a simple map, not an unordered map. And because the map is not unordered, we know that in this map, the keys are going to be in a sorted format. Very, very important. And because it's going to be in the sorted format, if you find a string rather, which has a frequency greater, then frequency becomes it.second, answer is it.first. But the next time, that's not going to happen. Does that make sense? Yeah, that's true, Ayush. That might not happen in Java. So this is a very good feature in C++. So over here, if you come to example number 2, what would have happened is against bad, good, and okay, 2 would have been stored. That's true. But in the storing order would have been bad, then good, and then okay. Because of this, you know that if you are storing the frequency 2 for the first time, you are storing it against the word bad. And then good and okay never come into picture because their frequency doesn't cross 2. Make sense? Yes, guys? Okay. So this is a very, very important point. And this should be remembered because this also affects the time complexity. because normal maps and normal sets give you an extra log n factor, whereas unordered maps and sets don't give you that factor. So you could have used unordered map also, but then you would have not been able to do this code like this. Some different implementation. Idea should be same. Let's go to the time complexity part. Very, very simple. You are iterating in this responses array. So maximum, this is 1000 order, correct? Then you are iterating in the array again. That is also 1000 order. That's 1D array. And they're inserting in the set. Now set insertion is pretty much constant because this is an unordered set. Although because you're maintaining duplicacy and there is a string insertion, this has to be multiplied by the length of the string that you are inserting. So maximum length is 10. So I can say this is roughly 10 order. Okay. Then after this, you iterate in the set. This is again duplicacy. So this is like 1000 order. And this can be said because this is not an unordered map right now. This is an ordered map. So you would have some sort of a log n factor again, right? Log n factor again, log of, you can say, the number of insertions that you do inside this. So maximum, I can say that I have 1000 different strings maybe in that scenario. Maybe that works out. So that can happen. Yes. And that is not going to be very, very large into the check that is 10 inside map also. Great. Now you have the order of going inside the map. That's 1000. And then pretty much everything inside this is constant. So what is the time complexity? In worst case scenario, I have actually come up with a time complexity that looks something like this. This is like 1000 into 1000 into, so this is 1000. And then you have into 1000 into 10. And then log of 1000 is pretty much, like, it's not very large. It's like a, you can say 5 or 6 factor maximum. So this is just on the borderline, by the way. This is not very, very optimal, but this is just on the borderline. This is going to work. And what about space complexity? Space is O of 1000 only. Either you take the set or the map. You can just say that you have, like in the worst case, even if you have like not 1000 strings, maybe every string can be unique. So let's say you have 1000 into 1000 strings that are unique. In that case also, this is like 1000 into 1000. So space is also fine to do. Okay. Time is done, space is done, and this will sum it out. Great. Any doubts, guys? Can you move on? Next problem. Let's start. So there are n types of unit indexed from 0 to n minus 1. You are given a 2D integer array conversions of length n minus 1, where conversions of I is source unit of I, target unit of I, and conversion factor of I. This indicates that a single unit of the type source of unit of I is equivalent to conversion factor of I units of type target unit of I. So very complex language. We'll just see the diagram and understand. What do we have to actually do? Return an array base unit conversion of length n, where base unit of I is the number of units of the type I equivalent to a single unit of type 0. Answer can be large. So we want modulo 10 power 9 plus 7. Okay. So let's see this diagram. Let's understand this. Let's say the conversions look like 0, 1, 2. Now, what does this mean? This means that from 0, if you go to 1, your conversion unit is 2. So you can say there is a 0 node over here. This is the 1 node. And it's joined by 2. So going from 0 to 1, this is 2 conversion. Now, the next thing is 1, 2, 3. That means going from 1 to 2, you have a 3 unit. Now, why is the answer 1, 2, and 6? So first value should be obvious. The first value is 1. This value is related to 0 or the 0th node. Now tell me, guys, how much unit conversion do you want to do to convert the 0 node to a 0 node itself? 1 unit, correct? That's the equivalent of 1 unit. So this value actually is always going to be 1. Now let's talk about this value. This value says that how much unit conversion is there from 0 node to 1 node. So from 0 to 1, you are going 2. So this is 2. And then this value is 6. Why is this 6? That means going from 0 to 2, you would require 6 units. How is that coming? Very clear from the diagram. In the 0th node, if you want to convert from 0 to 1, you basically have 2 as the conversion factor. And then this 2 is again multiplied with how much more units? If you want to convert from 1 to 2, that is 3. So this is 2 into 3 of overall conversion unit. That is 0 to 2. Answer becomes 6. And hence you save 1, 2, and 6 in your answer. Okay. I hope this part is clear. let's come to example number 2. I think example number 2 is something that has not been drawn over here. So this is going to be a little tedious. Maybe we can try to like correct, Ayush. That is a good observation. So I'm leaving example number 2 on you guys. You can try to draw this diagram once and try to think this that you are going from the type 0 to any type of other node. And as you go along the line, you just want to find that on that path, you are able to multiply those values. And I'm pretty much sure you will be able to come up with some output. That looks like this. Okay. So the question part should be clear. Yes, guys. Yes, Ayush is saying an approach also. Everybody else in the chat, I think question is clear to you guys. Great. Thank you so much. So let us begin for an idea. Let us begin for an approach. So first of all, I can see that the constraints are in 10 power 5 order. Because of that, I am looking for something that's linear or maybe like n log n maximum. I cannot go in n square order or something like that. Okay. And also I am always starting with 0. So basically I want to check whether I go from 0 to 1, then 0 to 2 and so on, so on, so on. This has to do. So I'll give you a simple diagram over here. Let's say this is node 0. This is node 0. It is connected to, let's say, 1 node, then let's say 2 node, then 1 is connected like 3, like 4, let's say something like 5, then let's say this is 6, and then this stretches out even further and so on. This stretches out and so on. Now, the problem over here is that if you actually start with node number 0, and let's say I tell you that, okay, tell me guys, can you find the conversion factor from 0 to, let's say, this 3? Now, looking at the problem itself, you can say, yeah, it's very easy. I would want to start with 0, somehow land it till 3. And as I go along this path, whatever these values come up, let's say this is x, this is y, I'll just multiply x into y. Is this correct, guys? Yes. The problem now is that doing this for 0 and 3 is something. Okay, should I make example? Thank you so much, Karan. I'll do that. Thank you for pointing if that helps. So 0, 1 and 2. Okay, so let's see. You have 0. Okay, this is 1. And the value here is 2. Then you have 0, 2 and 3. So 0 to 2, the value is 3. Okay. Then you have 1, 3, 4. Great. So 1, 2, 3. This is 4. 1, 4, 5. So 1 to 4, value 5. 2, 5, 2. 4, 6, 3. And then you have 5, 7, 4. Okay, great. Karan, is the diagram clear? Yes. Now let's try to figure out answers. Let's say I ask you the answer for 0 to 7. What do you do? What do you do over there for 0 to 7? You basically go for 3 into 2 into 4. Is that right? Correct? So 3 into 2 into 4, what is that? This is equivalent to 24. So we know that the last answer is 24. So this makes sense now? Yes? Simple, correct. We are moving by multiplying the factor. That's right. Now, coming back to my initial question. Let's say that I found the answer from 0 to 7. Or rather, let's do something. Let's say that I figured out what is the answer from 0 to 5. Now tell me, if I have to find out the answer from 0 to 7, do I want to again start with 0? If I want to find, if the answer over here, the answer for 0 to 5 is already known to me, let's say that answer is x, then do I want to find out the answer starting from 0 to 7? Or better, can I say that this answer x can be just multiplied x into, you can say x into 4. Can I just multiply x into 4? And I'll get the answer from 0 to 7. Is that right? Yes. So this means that basically I am looking for some sort of a technique where I am able to traverse and not go back every time. This is something I want to avoid. And this is why this problem can be identified as a problem where a traversal is required. Traversal is required. Okay. Added to that, you can also observe that there are some small values that are circulated out. So they can be called as nodes. And then you have connections from going some place to some place, which are edges. So if I accumulate all these things up, traversal is required, nodes are there, edges is there. Is this enough information for you to understand that this is a graph problem? Graph-based problem rather. Sort of like a graph-based problem. Correct? Is that right? Or even like a tree problem, you can say. Like you can also imagine this to be a tree because this has n-1 nodes. That's fine. Correct? Praveen is saying yes. So this is the intuition that you should have had. Looking at the diagram, it should have been clear that these are edges, these are nodes, and I'm looking to traverse smartly. Hence, this is traversal problem. Now, this is where prerequisites come into picture. You need to know some traversal technique in order to do this. And specifically in this question, the best technique that we can follow is BFS. Is that right? I think BFS is the best technique you can follow. Okay, like sort of a BFS technique you can follow. So what we can do now is we can try to see a small pseudo idea of the code piece and see what do we want to do. So what we'll do is first, if this is a graph or a tree, whatever you have, you need an adjacency matrix. You need an adjacency matrix, adjacency list, adjacency matrix in order to traverse. So what will that matrix look like? First of all, tell me guys, I think I did not draw this over here, but tell me, are these edges simple edges? No, right? They're not simple edges. If you go from one node to the other node, you cannot go up. So these are directed edges. Directed rather means going from one node to the other and not the other way around. Not undirected, but rather directed edges. Now, because these are directed edges, all I want to create the agency matrix is to look something like this. Over here, I think I have, what do I have? I think I have this, conversions vector. These has three values: source, target, conversion factor. So what I can do is I can say that, let's say I have a vector of pair of int, int type. Let's call this agency. And what do I want to push in this? Every time I am standing at some particular three triplet based value in the conversions, I want to make sure that agency of the first value, inside that I push back a pair of the second value and the third value. Is that right? Where what is the first value? This is the source. Second value, this is the target. And this is the factor, conversion factor. So is the adjacency matrix going to make sense? What will happen for this diagram? You will be able to push that, okay, 0 has two connections, 1 and 2. 1 has two connections, 3 and 4. 2 has one connection, 5. 3 has no connections, 4 has the connection to 6, 5 is the connection to 7. So your adjacency matrix should be clear. Can everybody picture this in their mind? If not, you can pause the video right now, guys. Not the live people, anybody who's watching this recorded. Pause the video and think of this adjacency matrix. What will happen when you push back for all the stuff? Clear? Now, once that part is done, I want to run some sort of a BFS algorithm so that I am able to start off at some location and slowly come down the graph. Correct? Now, where do I want to start with, guys? What is the first location that I want to start with? Obviously 0. So I can say that BFS will have a queue, and that queue is of the simple int type because I know that I'm just pushing the nodes in this, and then I have a value vector. So this is my answer basically, that okay, what are the conversion factors against everything? So I can say value array, And in the value array, the 0th node has a value 1, which is very obvious. The 0th node's conversion factor is 1. And in the queue, I can push. You can say queue dot push 0. Clear, guys? So I hope all of this should make sense and this should be striking. Now, how does a normal BFS algorithm looks like? You run some sort of a while logic. You say till q is like not empty. What do I want to do? You can take a queue of pair to make it simple. I mean, I'm not going to like the queue is only maintaining nodes, Ayush. So it doesn't matter if like you don't need to take it as a pair. Okay, what I'll do something over here. I'll show you. What I'll do is I'll first pop the pair, the individual node. So I know that, let's say int node is equal to q dot front, and I'll do q dot pop. Now, what do I want to do? I want to iterate in the, you can say, children of this node. So I'll say, okay, for auto, let's say it, in adjacency matrix of u. So it's adjacency of u against adjacency of u, whatever is saved as a pair, where the first value, that is it of 0, like it of, sorry, not it of 0, rather, it dot first is going to be the child that is connected. And it dot second is going to be the value of that edge through which it was connected. That is value v. Is this making sense? Yes. And now what do I want to do? Imagine this tree over here. Let's say you would have already done everything till this much location. Now you went to 5 and you said, okay, for this guy 5 over here, I would have gone in the child. And if 5 had more children, that's a different thing. But let's say 5 right now has only one child. I would have said, okay, till 5, the answer is calculated. So I know what is the value of 5. That is 3 into 2. So that is 6. So I'll say that for this node, that is val of 7, this becomes val of 5 into this edge connection, that is 4. And this is how I update. Is this making sense? Yes. So I would write a very simple idea. I will say, okay, let's update this in this fashion. I'll say something like val of v is equal to val of u into, this is u into c, or c or it dot first, whatever that is. And now because you want that the answer does not go very high, integer overflow doesn't happen, you can take a mod over here with m, capital M, where capital M was 1e9 plus 7. I hope the question is clear, guys, and the approach is making sense. Yes. Again, this is prerequisite of BFS. It's not necessary that you understand this in one go. It might be a little overwhelming. Pause the video, understand graphs and tree traversals to be specific, and then come back over here. I think you will understand this. Let's move on to the code part. Okay. So this is what I'm going to do. I have the mod I've taken outside this function. So I have mod as 1e9 plus 7. And then after that, I have n conversion.size, the adjacency matrix. Initially, the rows is n plus 1 because I know I have n plus 1, or rather n nodes maximum from 0 to n. So that's the upper limit that I've taken. Then I go inside every conversions, and the triplet that comes, it.0 is source, push back a pair made of it1 and it2. Then the value vector, the q, value of 0 is initially 1, and everything else is -1 because they haven't been, you can say, calculated as of yet. And then you push 0 in this. While the queue is not empty, you iterate, you pop, you go inside to the agency matrix. If the child, that is v, is -1 as a value, then you know this child's value has to be calculated as of now. How do you calculate that? Value of u, that is its parent, into f, that is the edge value, mod overall, and then you push v so that you continue this BFS idea. And this happens, and everything gets calculated. When you come out, you know val is all good to go. Clear, guys? I hope the problem is clear. Any doubts over here? Anybody? Let's quickly discuss the time complexity. This is going to have an n order. right? So you can say this is n order. Then pushback is pretty much constant. Then this is BFS. So BFS is sort of dependent on like a n plus m order, where n is the number of nodes, m is the number of edges. Now over here, the edges and the nodes are all similar because you have length also as n minus 1. That's the number of edges roughly. So you can say this is like n plus n, or something like 2 into n, or basically n order overall. So you know you have actually done the problem quite nicely, and this time complexity is O of n order roughly, which is going to work for a 10 by 5 order. What about space complexity? That is also O of n. That is dependent on the adjacency matrix and the cube itself. Vector is also n size. Everything is n overall. Okay. Guys, the problem is clear. Should we move on? Should I cover the last question before C? Yeah, okay, Tanuj, I can do that. No worries. Praveen, do you also want that to happen? Okay. Okay, let me do that. No worries. Great. So I hope this part is clear. So anybody who's watching this, this has been a request. So let's actually move to question 4 first, and you will find the appropriate timestamps in the video. So don't worry about that part. Let's go. So you are given a directed acyclic graph DAG with n nodes labeled from 0 to n minus 1, represented by 2D array edges, where edges of I, U, UI, Vi indicates a directed edge from node UI to Vi. Very, very simple. This is again prerequisite of graphs. So anybody who hasn't read graphs, read that and come back. Again, that is going to be a problem otherwise. Now, each node has an associated score, that is score of I, representing the score of that node. You must process the nodes in a valid topological order. Each node is assigned a 1 based position in the processing order. The profit is calculated by summing up the product of each node's score and its position in the ordering. Return the maximal profit achievable with an optimal topological order. Okay. So let us understand this question by this particular example. So what is given over here? You have a very simple graph, 0, 1, 2. So 3 nodes, that is 0, 1, 2. Edges are 0 to 1, so it's a directed graph, 0 to 1. 0 to 2, so 0 to 2. And then the score corresponding to every node is 1, 6, 3. So 0 node has 1 score, 1 node has 6 score, and 2 node has 3 score. Now you want to process this graph in a topological manner. Now, first of all, very, very simple to understand is what is topological order. Do you guys have an idea in the chat? What is topological order? So topological order basically means that if let's say you have 0 to n minus 1 nodes, okay? Let's say for example, let's say you have 1, 2, 3, 4, 5. Let's say you have 5 nodes in the graph. Now, once you start processing these nodes, let's say you note down the order in which you have processed. Let's say that you process the nodes 4, then you process 3, then you process 1, then you process 5, and then you process 2. Now, this order of processing is a valid topological order if in the original graph, any connection between U and V, if it was there, then in this order, U should come before V. For example, if in this node, let's say I pick up 4 and 5, and let's assume that in the graph, there would have been a connection between 4 to 5, where 4 to 5 is the connection. Since it's it's directed graph, so there is an edge between 4 to 5. If that is true, then over here in the order, you can see 4 is coming before 5. So that means this order is right. Let's say there was an edge in the graph, which looks like this. From 2, there is an edge to 1. Now, if in the graph, there is an edge that is from 2 to 1, but if you look over here in this order of processing, 1 is coming before 2. This is wrong. Why? Because the connection was from 2 to 1. So in the order also, 2 should have come before 1 and not after 1. Is this making sense? So this order now is not topologically correct. There could have been some other order of processing, but it is only topologically right if all these edges, I just stated 2 by the way, for example, but it applies to all the edges. All these edges, any U to V you pick up, U should come before V in this order. Is topological making sense, guys? Any problem? Okay. So the first thing is that you want to process these nodes in topological manner. Fine. So let's pick up this. Now let's see what do you want to do. So in this case, the node order processing is given as 0. Then you process the node 2, then you process the node 1. Why is that? If I process 0, then 2, and then I process the node 1, then against 0, I have the value as 1. I think, what was the value? Yes, 1. Then against 2, the value is actually 3. And against 1, the value is actually 6. And I'm processing them like this, 1, 2, and 3. So profit happens in this way. Profit says 1 into 1 plus 2 into 3 plus 3 into 6 is what we print, I think. Is that correct? So we say, let's add this up. This becomes 25. And this is the highest profit gained. Why? If I change the order, let's say I would have taken something like this, 0 to 1 to 2, then the order of processing is 1, 2, and 3. The values against them is 1, this is 6, and this is 3. But the value now is 1 into 1 plus 2 into 6 plus 3 into 3, which is actually 1 plus 12 plus 9. So that is 22. Now 22 is of course lesser than 25. Yes. Is that correct? 22 is lesser than 25. So we know that this is a better order to follow. Clear? Hence we follow this order and we get the answer. Now what is asked? They are not asking you to print this order. They are just asking you that best topological order that you would have followed would have given you what answer, print that. So I know that this sort of an order follows and gives me the best answer, that's 25. So I'll print 25. I hope the problem is clear. Yes, in the chat. Okay. I think somebody is saying, okay, so Arod is saying that greedy will not work. Yes, that's very right. So first of all, how many of you think that greedy should work? And if not, can you reason why? Why will greedy not work or why will greedy work? Madhu is saying yes. Ayush, yes. Yeah, n is only 22. Correct. That's very true. We'll come to that part. But first idea should be, why does greedy not work? First of all, what is greedy in this? The greedy thing to do, of course, in this is go for nodes which have higher score in very later manner. Yes, I can go for nodes which have high score later. If I do this, then I overall will increase my sum a lot. Data is not consistent. No, that's not the idea. See, Ayush, I'll give you a very simple example. This is not given in the examples, by the way. See, nowhere is it written that this is a single graph. Is it written anywhere that this is a single graph? Can the graph not look like this? Let's say there is a node A1 connected to A2. And there is a node B1 connected to B2. This is also a graph, right? It has two different components, but it might not be connected itself. It's not a single chain. Correct, Tanuj is right. Two different components. Now in this case, you don't know what do you want to process first. Because greedily, if you process right now, you might be wrong later. For example, let's say the value against this A1 node is 100 and the value against B1 node is 1. So what will you process right now? Guys, tell me. What will you process right now? I don't know. I'm not commenting about A2 and B2. In A1 and B1, you can process any of them, but you are greedy. So you will say that, okay, let's try to process the node B1 first and A2 later, A1 later. Because if I process B1, then I'll be multiplying 1 into 1 and this would be 2 into 100. Correct? So you say, okay, let's process this first, then this is second. Now, after this, what will happen? What will happen is, let's say there is, now, what do you want to process further? What do you think you should process further now? You're maintaining a topological order, right? So what happens now? Maybe A2 and B2 have values, or maybe graph below them have such values for which this choice was not optimal. It can happen, right? Because just at this location, it might seem that processing B1 was better. But what if B1 has better values later on in the graph? Doesn't seem an optimal choice now. Does that make sense? Yes? So there is no consistency in components also. There's a lot of different choices you can take, and you cannot guarantee a greedy idea. Sort of, yes, correct. So I was saying that data is not consistent. Take greater value at any point. It may happen, it end without max value. Correct, that's very true. That's the idea. Correct, Ayush. So I just give you an example in different components also. Okay. So does everyone agree now in the chat that greedy idea will not work? Okay. Anybody who's watching this problem later, please try to make some cases. Or maybe I can say, guarantee you can actually try to write a greedy idea, submit it, and come back. You will understand why this not working. Great. So once this is clear, now comes the picture. How do I put the next intuition? Now, this is a very important thing you guys can note. I'm giving you this by experience. Whenever greedy does not work, what is greedy essentially? Greedy essentially is that there were many paths to take, and you greedily decided that you will only take some specific paths. This is called greedy approach. Okay, I'm going to do something specific, some specific path. This is called greedy. But we just decided that going through a specific path is not right. That means I want to go through all the paths. Correct? This is not right. This is right. Now, if I want to go to all the paths, then I need to bring something called as DP. Is that right? This is what essentially DP is. DP says that you will be exploring everything and getting the right answer. Is that right? Yes. So is the intuition part clear? Why do we want to go with DP? Okay. I hope this part is clear. Now coming to the point that, okay, you said we want to do DP, but what would be the states in DP? How do we maintain that and everything that comes into picture? This is where constraints come into picture. If we, that's Madhu, that's correct. Exploring all the paths. If you want to explore all the paths, Madhu, and you want to do that in an efficient way, you would want to apply DP. So now the question comes, what is every DP going to look like? What are the states, everything, all those terminology come into picture. Any beginner who's watching this, by the way, as I said, this is a hard problem. Please understand DPs, graphs, and all this part to solve this problem. And if you do not do that, it's going to be a little tedious. From here on, even more. So let's continue with the idea. We now want to look at the constraints. If I check over here that n, that is the number of nodes in this graph, it's very small. That's just 22. It's a very suspicious value, right? It's not 1,000, it's not 10,000, the normal values that we see. It's like a very small value in the 10 range, right? Order of 10 range. So what does this hint me? This is again by experience, guys. What happens is, if you look for a DP, you look for the complexity that might arise through DP. Now, I just said that you would want to explore all the paths. What is basically saying I want to explore all the paths? All the paths means that I want to make sure I am able to go through all the nodes, all the possible options to choose all the different nodes at all single point of times. And through that, whatever answers do I gain, I want all of them. That's a very high possibility, right? That might be a lot of paths. But because the number of nodes are very, very small, this means DP can be applied. And rather, I'm giving you this by experience also, if the constraints of the state in DP, the main thing that you want to maintain, in this case, this is nodes, okay? Or the other times it can be some other value, some X, some Y, anything that is, if it's in order of roughly 10, order of 10, okay? Order of 10 means it's like 8, 20, 15, something like that, then bitmask DP comes into picture. You can apply DP and you can apply bit masking DP, or bit masking as a topic comes into picture. Is this clear? Is this clear, guys? No, not brute force. Now, what is bit mask DP? What is bit masking in general? I'll give you a very small idea over here. Bit masking. So it's two words basically. This is like bit mask. So bit is 1 and 0. 1 and 0. And mask is like in English also, this is mask, the thing you wear on the face, or generally mask over here is the representation of the state in zeros and ones to store some info. Over here, what can we store? What would we want to store? I'll give you a very simple example. Let's say I have a value that looks like 1010. This is the 0th node. This is the first node. This is the second node. This is the third node. Now, if the mask value is 1010, this means that the third node has been visited. The first node has been visited. The second node has not been visited, and the 0th node has also not been visited. And how am I storing this info, guys? How am I able to store this info, guys? I think it should be fairly obvious, right? 1010. If the bit is turned on, then that means it's saying yes. So I am saying that the information connected to it is, has that node been visited? So when I make traversals in this graph and I'm able to visit a node, I'll make sure that the mask value is turned on, or the mask inside that mask value, that particular bit position is turned on. And if it's not that case, it's not turned on. Okay. Now, what comes into picture over here? Why is n as 22? Because you can actually create a mask that is maximum of 22 bits. You can have a mask that has a size of 22 bits. You have 22 nodes, maximum 22 bits. Now, because you have 22 bits, you can basically now figure out that, okay, I will be able to maintain this data very nicely, whether a node has been visited or not in this 22 bits. Whichever bit is turned on, I'll say corresponding to that position, that node is visited. If it's not turned on, I know it's not visited. So is bit masking making sense? What is bit masking now? And what is the information? Okay. Is this clear, guys? How we choose mask? Okay. Tanuj, so I'll tell you this part. How do we choose mask? So Tanuj, how will we choose mask is, so over here, what do we want to start off by? We want to start off by processing the nodes which have, like in the cyclic manner, I can start off with those positions. In this case, let's say I can start off with 0. Correct? Tanuj, I can start with 0. So I'll give you this example only. Look over here at the diagram. This is the 0th node. This is node 1. This is node 2. Now I only have 3 nodes, Tanuj, right now. So what I'll make sure is my bit mask is of 3 size. Everything is 0 right now. No node is visited. Now when I, Tanuj, go to the first node and I say, okay, first node has been visited, then this mask will convert from 000 to 001. Is this making sense? Why, Tanuj? Why does it convert from 000 to 001? Because the 0th node has been visited, which is at the 0th place from the right side. So that bit is turned on. Now, next time, let's say you visit this bit, this node, that is node 1. So when you are standing over here, the node 0 and the node 1 both have been visited. So your mask will change from 001 to 011. Is that correct? Is this making sense, Tanuj? How is this changing? Okay, cool. So let us move on ahead with the question. Now, let's come to this point. So I'll ask you a very important question over here, guys. Tell me that if there is a random node V, I am picking a random node V, then to process this random node V, topologically, if I want to process this node V, then what has to satisfy? There is a node V. This node V must be connected somewhere from the above, right? Maybe it is connected from 4 locations. Maybe that is happening. Maybe this is some node U1 from which it's connected, U2, U3, U4. Maybe so on, so on. So if I want to process the node V, then tell me, guys, what has to satisfy? In degree should be 0. Yeah, like that is the topo sort method. But one more thing that we can simply say is that above node should come, correct, above node should come before V, as in Tanuj, if I want to process V, then the node U1, U2, U3 and U4 should have been processed already. If these 4 nodes are processed, then only V can be processed. Is that right? Is that correct? Is that correct? Okay. So this node V should be processed after all its predecessors have been processed. You can say predecessors have been processed. Is that right? Predecessors have been processed. That means that when I actually when I'm traversing the graph, or when I'm traversing the graph using the mask rather, okay, when I'm traversing the graph using the mask, if I actually go and stand at V, when I come down to V over here, during that time in the mask value, the bits corresponding to U1, U2, U3 and U4 should be on. Is that right? Should be on. In this mask, these 4 bits should be turned on. ये समझ में आ रहा है? Is this making sense, guys? Akshat, yes. These 4 bits in this mask should be turned on before I come to V. Yes or no? Is that correct? So what I'll do, I'm going to now give you an idea of the code. What I'll try to maintain, I'll say that, okay, first I'm going to find something called as predecessor. Like this is going to be predecessors array. I'll call this spread, where each value, let's say I find predecessor of I. Predecessor of I will represent that this is going to be a mask value of all the nodes who are the parent, or you can say predecessor of I node. So let's say I am asking you guys, let's say for the node 2, who is the predecessor? For the node 2, the predecessor is 0, right? So for the node 2, what is going to be the pred of 2 value? It's going to be 0, 0, 1. Is that correct? Is this making sense? Is this making sense? For this node 2, the predecessor is 0. हो सकता है node 2 का कोई और भी predecessor होता. Maybe node 2 was connected from some node 3 also over here. Had that been the case, then predecessor of 2 would have been, you can say 0, sorry, not 0, 1, 0, 0, 1. 0th node, 3rd node, 2nd node, 1st node. 0th node is turned on, 3rd node is turned on. Simple. Yes, because the node 2 is having predecessor 0 and 3. Is the predecessor array making sense? For 2 and 1, both have 0, 0, 1. Yes, Akshat, correct. Right now, if I don't take this example, then for both predecessor of 2 and predecessor of 1, you have 0, 0, 1. That's absolutely right, Akshat. Clear? So predecessor of I makes sure that this is the mask value of all the nodes who are, you can say parent or predecessor of the I node. We are using mask for tracking visiting nodes, right? If yes, then we can do with vector just like we do basic traversals. Yes, we can do that also, Tanush part. Like what I'm basically maintaining over here is very easy, because now when I have a predecessor array, no, it's very easy for me to make sure that the ith node is only visited after its predecessors are visited. अगर मैं ये काम नहीं करूंगा ना, then you will have to go through a algorithm called as Khan's method. This is also very good. Sorry, this is also a very good question. Khan's algorithm rather. This is where in degrees come into picture. Okay, so anybody who's watching this topic and wants to solve this problem using this algorithm, you can also do that. You would have to now maintain in degrees, and only when a node's in degree is 0, you would want to visit it. But right now I am maintaining predecessors. mask, and using that mask value, I'll be able to make sure I actually visited only once the predecessors are visited. How will I do that? I'll actually show you. Okay. So up till this part, this is clear. Predecessor of I is clear. Okay. Now let's declare the DP. DP of mask. What is DP of mask? When I say what is DP of mask, DP of mask is going to be the best possible profit made from visiting the nodes turned on in this mask. So, for example, if I come back to this particular question, if I ask you guys what is the answer, then don't you think the answer is DP of 111? Isn't the answer DP of 111? That means all the nodes are visited. Is that right? Yes. Isn't DP of 111 the answer? Correct? Great. So I hope this part is clear. So we declare a DP of mask. Now I am going to show you not a iterative approach. I will keep this recursive plus memoized approach because I think that is something people more better understand. So let's try to see. What will I do? I'll say, okay, initially all the spread array, everything right now is 0 in this. Everything is 0. Now first let's make this predecessor array. How do I make this array? I'm going to go for auto it in edges. I'll go in every edge. Edges. Now I know u is it of 0 and v is it of 1. So what will I do? I'll say in the predecessor of v, you can say it is equal to predecessor of v or this is bitwise or. Okay, this is a big or, bitwise or 1 left shift u. Tell me guys, how many of you understand this? Tell me how many of you understand this. See, predecessor of v is going to be a mask value. In that mask value, I'm trying to turn on all the places where I know that u is coming into picture. Yes. So I'll say that, okay, let's say u is 0th node. So the 0th bit is turned on. Let's say u was the 4th node. Then the 4th node is turned on. 4th bit is turned on. If it was the 5th node, then 5th bit is turned on. And how is that going to happen? 1 left shift 5 means 1 0 0 0 0. And when you will OR it with predecessor of v, this 5th location will be turned on. Because you know ORing any value with ORing any bit. If you take a bit and you OR it with 1, you basically get 1. Is this making sense, guys? Yes. So this is how I'll grade the predecessor array. No problem. Understood. Now let's move on. Now I am going to assign the DP. And the DP is going to have how many states? How many possible states are there, guys? 1 left shift n. And everything is -1. Correct? Nothing has been as of now calculated. And the total states are 1 left shift n because there are n nodes. Very simple. This is the initial assignment. And after this has happened, I am going to call the helper function. Now let's see what the helper function looks like. This is the DP calculation. This is the memoization. Let's see what the helper function looks like. Now in the helper function, there is of course going to be a base case. There is a base case. What is the base case, guys? It's very obvious, right? If the mask, oh, by the way, sorry, if I call the helper function, I am calling the helper function by a mask value that is initially 0 because I'm starting with 0 mask. Okay. Now I'll say, let me call the base case. The base case is very simple. If my mask reaches a state where everything is turned on, that means I want to return from there. Is that correct? If the mask becomes 1, 1, 1, 1, 1, 1, 1, then I want to return. So I can say that if mask is equal to 1 left shift n minus 1, then I would return from here, I'll say return 0. Why is this working? How many of you understand this? This is a very smart binary check. You basically want to check whether mask has turned all ones. How do you check that? 1 left shift n, let's say n is 5. So 1 left shift 5 will be 1, 0, 0, 0, 0. And when you do minus 1, this will actually be 1, 1, 1, 1, 4 ones. So this is how you'll be able to check. 1 left shift n minus 1, this value is going to be all ones. And if the mask is equal to that, then you want to return from here. This is the base case. Any problem? Yes, in the chat, guys. Okay, clear. Let's move on. Now comes the main idea. First, obviously, this is memorized solution. So if dp of mask is already calculated, it's already equal to, sorry, not equal to -1, then I want to return dp of mask. If it's already calculated, I want to return dp of mask. No worries there also. No worries. Okay. Now let's move on. Now comes the main thing. Base case is not there. It was already not calculated. That means I have right now a mask value. Now, if I have a mask value, in this mask value, somewhere it will be 0, somewhere it will be 1, somewhere it will be 0, somewhere it will be 1. For example, this is the mask right now. For example, it looks like this. Now tell me, looking at this mask, how do you know how many nodes have been processed? Can you tell me? Looking at this mask, how do you know how many nodes have been processed? Very simple. If you count the number of ones in this, that is the number of nodes you have processed, right? If the number of nodes is 5 in this, basically the pop count value or the number of ones turned on in this value is the number of nodes you have already processed. So if right now the next node that you are going to process, the node that you're going to process is V, then what is the order in which you're processing it? It is actually the built-in pop count value of mask plus 1. Is it very simple to write? The mask value is the number of ones in this mask is 5. 5 plus 1 is 6. So this guy, this V node, is the 6th node that I'm processing. Is that correct? So the order right now is mask, or this is again, when I write bar of mask, this is not absolute value. This is just an expression of writing number of turned on bits in mask. Clear, guys? Or pop count. This is called pop count. Clear? So now I know that I'm standing at a V node and the order is also calculated. Okay, fine, clear. But now this V node, which is that? This node V is going to be which of the node? How do I know that? I don't know that. So I would want to run a for loop. I'll run a for loop. I'll say int V is 0. V is less than n, V plus plus. Let's go to each and every node. Now, when I'm inside each and every node, I'll say, okay, first, let me check whether this node has already been processed. Ye bhi to sakta hai na, this node is already processed. Let's say you're checking this node. This node is processed, right? So why do you want to process this node again? You don't want to do that. How do you check that? How do you continue from here? You will say that if mask and 1 left shift V is some value, then you want to continue. Is this correct? Is this correct? This is again a method of checking. There are 10 different methods to check this. You basically just want to check from this line. The purpose of this line is to check whether this V node has already been processed or not, or is it turned on in the mask or not. So you can check it however you want. You can maybe make sure mask is right shift V times and then check it, whatever you want to do. It's totally up to you. This is just one method of that. Okay, so you will continue. But if this is not turned on, then you would want to process it. But if I want to process it, what's the primary condition that should be satisfied? This is something we just made sure. The main thing we made sure. If I want to process a node V, then all its predecessors should be processed or not. Is that correct? Is that right? So if this node V has not been visited and I want to process it, then I know that the mask value of predecessors of V, okay, the mask value of predecessors of V ANDed with the not of this current mask, not of the current mask, should give me 0. Is this making sense? Is this making sense? What did I write over here? Predecessor of V stores the mask value, that is which are the nodes which I would want to process before V. And when I take not, this is a small tilde that I have actually put. This symbol is called tilde. Okay, you can see this symbol right next to the 1 in the keypad. When you take the not of the current mask, that means that if your mask looks like this right now, it will change to 1 1 1 0 0 0 1 1 1 0 0. Basically, every 0 converts to 1 and vice versa. So this becomes the current mask value. If you take the AND of this mask and the predecessor's mask, if predecessor's mask looks something like this, let's say 1 1 1 0 0 0 0 0 0 0 0, and when you AND this, you will get 0 or whole zeros. Is that right? And what does this information tell you? Doesn't this information tell you that all the nodes for the predecessor of V have been processed? So V can be processed. Is this making sense, guys? This is very, very important. Again, this is 10 different implementations that you can do. I'm just making sure that you understand one of them. Is this making sense? Ravini is saying yes. Other people? Ayush, Tanuj, Madhu. Okay, great. So I'll say that if predecessor of V, okay, Arod. So Arod, what I'm saying is, imagine Arod that the node V that I had right now, the predecessor mask of that node V looks like this. As in this node, this node, this node are the predecessors of V. Now, if your mask value looks like this right now, and you take the not of that mask value, it will look like this. And when you will AND this, basically this zeros will make sure this is 0. These zeros will make sure this part is also 0. But over here also, don't you think this will make sure that this is 0? So overall, it will become 0. Correct? Is that right? If any other particular node has not been processed as of now, then what will happen is in this mask value, maybe let's say this was 0. So this will become 1. And when this happens, this value will not be completely 0. This is 0, this is 0, this is 0, this is 0, this is 0. This is also 0, but this is 1. And this 1 is a nightmare now. Because this 1 tells you that every predecessor has not been processed for the node V. So please don't process it right now. Making sense? Now, is it clear, Arod? If the mask contains from extra bit on it, it will happen. Yeah, correct. So now if this is 0, then I want to do my processing. What is that processing going to look like? Now I know this node V can be processed. So if it can be processed, then I will find the value of what I can achieve from this processing thing. So I'll say, let's take a call. Let's take a call over here. Let's say int something like res. The result that comes from processing this node is again calling the helper function. Inside this helper function, I am going to turn this value on in the mask. So mask bitwise odd with 1 left shift V. And this is what I pass. And then some best variable outside can be called as max of best, comma, res plus score of V into order. What does this mean? Actually, the code is going to look a little unclean over here if I keep on writing like this. Let me actually take you to the main coding part. Okay, I've covered most of the points. So let me take this. No incident. I don't think it's going to happen today. I'm so sorry. There were clash of two contests. I think it will happen tomorrow for you. Okay. Let's actually see the code part quickly and you will understand this. It's getting a very unclean over here to write. See, I have the predecessors vector and the DP. First, I assign n locations, everything is 0. I go in the edges and then edge of 1 odd equal to 1 left shift edge of 0. This is making sure that I make the predecessors array. Now I assign everything in the DP to be -1. Call the function. Inside this, let's see. The base case, if mask is equal to this value, return 0. If mask is not equal to -1, return it because it's already calculated. Else, what's the order? What's the position? The built-in pop count in masks, that is basically the number of ones in the mask plus 1. And then the best answer right now that I would want to calculate going onward, going from this mask, is initially long min. Now, when I go for every node from 0 to n, if it's already in the mask, continue. Else, if its predecessors and the knot of mask is 0, that means I can process it. So I'll call the function again by turning this on, passing the score and n as usual. And this is a candidate. This is one of these possible answers that can come. If it's not equal to long min, that I know that best can be made sure to be max of best, comma, this value plus what is the extra value that comes into picture? I have processed this V node. So score of V into position. In which order did I process it? Multiplied by the score of the processing. And when I come out of this for loop, I know that for this current mask value, I have figured out the best possible value that can basically come into picture. So that is equal to best. If it's equal to long min, then I simply store 0, else I store best. And by this method, I have made sure that all the possible masks have the best possible values stored. So when I return this function, I am returning DP of 1, 1, 1, 1, 1, 1, 1. Basically, all the values turned on or all the nodes have been processed. And I am gathered all the paths. I figured out all the best answers because I was taking a max function. So I know this is going to work. And this is my overall DP. Is this clear, guys? Is the code making sense now? Can you please again example? So Madhu, it's going to be very, very tough for me to explain with an example actually. Okay. Let me try to see. Let's take a very small example. Okay. Okay. Dry run. Tanuj, Khan's algorithm is something that has a very different approach. It would be very lengthy to approach to basically go for two approaches right now. What I can do is maybe in the description, I can attach a code that is solved by Khan's algorithm so that you have both the perspectives. Okay. Tanuj? Okay, let's see a dry run, guys. Let's see a dry run on the second case over here. Let's see a dry run on the second case. Okay. So now you have 3 nodes. So first, let's find the predecessor array. So I want to find the predecessor of 0, predecessor of 1, predecessor of 2. Predecessor of 0 is, of course, 0. 0, 0, 1, 0, 0, 1. Any problem in this? By this piece of code, any problem? Yes, this is making sense. Okay. Now, what is n in this? N is 3. So 1 left shift n means 1 left shift 3, which means 2 power 3, which is 8. So I make a DP which has positions 0 to 7. Everything is -1. So the DP has 7 0 to 7. 1, 2, 3, 4, 5, 6, 7, 8. Everything is -1, -1, -1, -1, -1, -1, -1, -1, -1. This is the 0th index, 1th index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index. This is DP. Any problem till here, guys? Okay. Now I pass the mask. Now is mask equal to 7? It's not. so I don't do anything. Is dp of mask calculated? No, it's also not calculated. So let me go forward. Let's find the built-in pop count in the mask. Now mask right now passed was 0. So the built-in pop count in this is 0. So 0 plus 1 is 1. So pos becomes equal to 1. So this is the first node that I'm processing. Okay. Now I'll go in the for loop. Let's go to the 0th node. 0 node, 1 node, 2 node. I went to the 0th node first. Now in the mask right now is basically 0, 0, 0. Okay. Mask right now is 0, 0, 0. Pos is 1. So I know that the mask and with 1 left shift 0 is not going to give me, like it is going to give me 0. So I don't continue because I know in this mask, this node is still not turned on. Now let's move. I'll say, is the predecessor of this and not of mask equal to 0? It is. The not value of this mask is 1, 1, 1. The predecessor of 0 is 0, 0, 0. So 0, 0, 0 ANDed with 1, 1, 1 is going to give you 0. So what I'll do is, I'll make the next call. The next call is going to be with a mask that is 0, 0, 0 odd with 1 left shift V. So I know that the mask value has changed to 0, 0, 1. And this indicates that the 0th node over here has been processed. And then I continue forward. Is this now making sense, guys? Are you able to imagine from here on? Do you want me to continue with the dry run? It's very easy after this. Like you just want to go to the node 1 similarly, node 2 similarly, and continue and find the best answers. Clear? Okay. So this is the whole code idea. I hope this makes sense. You can try to dry run this once. Okay, continue please. Akshat, okay. Let me continue quickly over here. See, once it became 0, 0, 1, after this, you make the call again. Then you check, is it equal to the base case? No, it's not. And then if dp of mask is not equal to -1, no, it is not still calculated. 0, 0, 1 is not still calculated. Find the built-in pop count in 0, 0, 1. So that is equal to 1. So pos becomes equal to 2. Okay, so you can write pos is equal to 2. Now you're looking to process the second node. Now you start with the nodes 0, 1, 2. Now 0 is already processed, so you continue over here. Then you go to 1, and this is going to be correct because predecessors of 1 is 0, 0, 1. 0, 0, 1 with the not of this mask, not of the mask is 1, 1, 0. 0, 0, 1. If you AND this, you get a 0. So you know that 1 can be processed. So you process 1 and you turn it on, and now the mask value goes from 0, 0, 1 to 0, 1, 1. Okay. And then from 0, 1, 1, you go forward. There is nothing more after that. So it's a leaf. It's like a leaf node over here. You process it, you come back. And while coming back, the best answer is updated. How is the best answer updated? The best answer is updated equal to, you can say 1 into score of V. Score of V was 6. And into position. Position at that time was 2. Position at that time was 2. So 2 into 6 is updated. And sorry, 2 into 6 is updated. And you continue forward. But that is not the correct approach. But like that is not the correct answer because that is something you would have not wanted to take initially because you don't want to process the first node on the second location. So next time when node number 2 is processed, you get a better answer from there. And you go in that direction rather, and you actually land up with 18 finally at the end, and 1 plus 6 plus 18 is of course stored. So dp of 1, 1, 1 finally returns 25 to you. Is it now clear, Akshat? It's very complex to show a bit case-based dry run. That's what I'm trying to just continue quickly. And it's going to take a lot of time otherwise. I hope this up till this part is clear. Okay, you can try this once on your own, and I think you will be able to solve this. Yeah, it is heavy implementation. As I told you, this is not a very beginner-friendly question. Okay. So now what is the time complexity, guys, quickly? The time complexity, see, you are running an N loop over here. And this mask is changing, and this mask, the possibility of changing of mask is like the number of different states this mask can have is 2 power n, because everything is bits, right? So either the bit can be 0 or 1, 0 or 1. So you have n bits, so 2 into n, 2 power n, which means this overall DFS call is actually running in n into 2 power n idea. Okay, which means the time complexity is O of n into 2 power n, and the space complexity actually is O of 2 power n simply. That is the DP size. Clear? Now this is going to work. 22 into 2 power 22 you will calculate. It's not greater than 10 power 8 ratio. That is why this works. Clear, guys? Again, any beginner who's watching this, you will get highly overwhelmed by the problem. So I recommend that you first go through the prerequisites of DP, graph, bit masking, and then come back to this problem. Do a very neat dry run and you will get this idea. Let's move on quickly. Okay, problem 3. Final problem. Let's cover this quickly in 10-20 minutes. The PCD is stretching long for no reason. So count the cells in overlapping horizontal and vertical substrings. You are given an m into m matrix grid consisting of characters and a string pattern. The horizontal substring is a continuous sequence of characters read from left to right. If the end of the row is reached before the substring is complete, it wraps to the first column of the next row and continues. And similarly, the vertical substring is also there. They've given you a very big definition. I'll actually tell you what that means. So this means simply is a horizontal strings looks like this. Basically, you start with the first row, A, C, C. And then you wrap yourself to the second row. Then B, 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 C. Then again the third row, A, B, A. Then again the fourth row, C, A, C. And so on, so on, so on. So basically your movement is left to right, left to right, left to right, left to right, left to right. And in this, the movement, this is horizontal movement. And the vertical movement is top to bottom. So top like this, A, B, A, C, A. Then again next column, A, B, A, then again next column, C, B, B, A, B, next column, so on, so on, so on. So you're basically moving left to right, left to right, left to right, so on, one to the final rows in horizontal, and in vertical, something like this. Now, what do we want to do? We want to find that we have to count the number of cells in the matrix that satisfy the following condition. The cell must be part of at least one horizontal substring and at least one vertical substring where both substrings are equal to the given pattern. So let's see this example. The pattern was A, B, A, C, A. So in vertical direction, this pattern can be found like this, A, B, A, C, A. This is red. And in the horizontal direction, it is found like this. You start with this A, B, A, and then you wrap yourself to the fourth row, that is CA. So A, B, A, C, A. Like this is the pattern. So in horizontal direction, you found one place where the pattern is coming. In the vertical direction also, you found one place where the pattern is coming. And in them, this cell C is the purple cell, which is intersecting with two strings, in one in vertical, one in horizontal. So this is the only purple cell, your count is 1. And this is what you want to find. Is the question clear, guys? I hope the question is clear. Yes? Okay. So now how do we find this? What are the main constraints in this that will come into picture? We need to first understand them. First of all, we need to be very smart over here and understand that we are trying to find a pattern in a string. But that string, if let's say I'm just talking about horizontal direction right now. Let's only talk about horizontal direction. If I talk about horizontal direction, are you trying to find this string in one row? Or rather, you can imagine that there was a very large string that was formed by, you can say, making a 1D array out of all the rows into a single cumulative string. Meaning, if I write a string that looks like this, something like this, C, then I write B, then I write C, A, B, A, CAAC, AAB. So I have written this string from the first row, second row, third row, fourth row, and fifth row in one continuous manner. And in this string now, can you identify that the pattern that is ABACA is coming over here? ABACA. This is the pattern that is coming over here. Now tell me, what is much easier to find? Is it easier to find the string coming in a 2D format, or now have I converted into a 1D format? It's better to find the string. Which is better, guys? The second option is better. Similarly, if I would have made a vertical string that starts from the first column, top to bottom, top to bottom, top to bottom, and concatenate it, it's better to find in that particular string. So our first idea is to create a horizontal and a vertical string out of the grid. Out of the grid. Okay, this is the first thing. Now the next thing that is there is to find that whether this pattern is coming in the string or not. Now how do we do that? The question is very clear, guys. I'll give you this question. All the people who must have done this question and understand string algorithms will quickly identify this. I want to find a pattern in a string, or rather all the places where pattern occurs in string. Okay, simple. Now this question is a very popular string question which can be solved by various string algorithms. I am going to use an algorithm called KMP. Is this clear? Anybody who's watching this after this video, pause and actually Google this question out. This is a separate question overall. Finding a pattern in a very good time complexity in a string. There is string hashing, Z algorithm, and KMP. I'm going to use the easiest of all, which I feel is very easy, is called KMP algorithm. Using KMP algorithm, I will be able to find exactly all those places where this string pattern comes in the horizontal string as well as it comes in the vertical string. Clear? No, Ayush, I think it's not possible to do this with a try, because try will require prefix idea, and there is no prefix idea in this. The pattern can lie anywhere in this horizontal string. Okay, so if you are going to make a try out of the horizontal string, then prefix thing should be there. Great. So the idea over here after this would be, after I have made the horizontal string and the vertical string, what I can do is I can figure out a simple KMP algorithm, and using this KMP string algorithm in a very good time complexity, find out where does the pattern occur in the horizontal string and where does this pattern occur in the vertical string. Now, once that is done, what is my next step, guys? Can you tell me? Let's say that the horizontal string looks like this. And let's say the pattern comes from here to here. It's also present from here to here. And it's also present from here to here. Let's say these are all the places the pattern is present. What do I want to do? Finally, what do I want to do? This is the horizontal string, let's say, H. Let's say the vertical string also looks like this. Okay, also looks like this. And in this, the pattern comes from here to here and here to here. So I have found this, that, okay, in the horizontal string, it is coming at 3 locations. In the vertical string, it is coming at these locations. What do I finally want to do, guys? Tell me. I want to figure out that this particular, let's say this particular cell, it is part of the pattern. And let's say this particular cell is also part of that pattern. Let's say this is extending to this location. So if this cell is also part of the pattern and this cell is also part of the pattern, and let's say these two cells are actually same in the 2D grid. Let's say in the 2D grid, these two cells are actually the same cells, the same I, j cells. Then don't you think this is a cell that I want to count as a purple cell? This is a cell where I know that it is also part of a horizontal matched pattern and it is also part of the vertical matched pattern. Is it making sense, guys? Isn't this something that I want to do? Correct? So somehow I want to mark in this particular horizontal array, somehow I particularly want to mark in this horizontal array that which cells are actually part of the pattern. So let's say that I'm able to mark them. Let's say I'm somehow able to mark like this. I'll erase it. Let's say that I'm marked that, okay, this cell, this cell, this cell, this cell, this cell, and these two cells come. these two cells over here, and let's say these 3 or 4 cells come over here. So I'm able to mark by ticks like 1 or 0 basically that, okay, these cells are coming in the pattern in the horizontal string. That means they are part of the horizontal pattern, and they're also coming in the vertical string. They're also part of the vertical pattern. Then all I want to do is somehow figure out that if I pick up this cell I comma j, and let's say this cell's I comma j, if they are same, if they are equal, that means both are turned on. If both are turned on, as in H also, this value is turned on, and in V also, this value is turned on, then I know this is a purple cell that I want to count. This is a cell which is common to at least one horizontal and one vertical. Is this clear, guys? Should we see an example on this? Should we see an example? Let's see the second example. Okay. I am just quickly noting this down. CAA. This is A, B, A. Yeah, we have to get IJ somehow. That's right. B, B, A, A. And then you have A, B, A. This is horizontal. And in the vertical, you can note C, A, B, A. And then you have A, B, A, B, A, B, A. Okay. See, guys, I've noted it over here. And the pattern is A, B, A. Now tell me, ABA is coming over here. This is horizontal. This is vertical. ABA is coming over here. ABA also comes over here. 2 places. Anywhere else is it coming? ABA? No. Then ABA over here comes like this. Then over here comes like this. Then over here comes like this. Then also comes like this. Yes, 4 places over here. So can I mark these cells? Let me mark these cells. This is marked. 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 Over here, this is marked. All of these are marked. Okay, clear? Now, how do I figure out? Okay, so first of all, one confusion that can be there. I'll quickly process this. If you look at this cell and this cell, they are not the same. Just because they are under each other, they are not the same. Why? Because the flattening of the horizontal string has happened from left to right, and it has happened from top to bottom. So these cells might not be same. So first of all, you need to find whether these cells are same or not. How do you do that? So I'll give you a very simple mathematics over here. Let's say this is 0th cell, 1 cell, 2 cell, 3 cell, 4 cell, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, which is correct because this is like 4 into 4, so 15 cells. And this is also 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. But actually, like, let's try to figure this out. Let's say I pick up this cell 5 over here. Okay. So this cell 5 actually is the 5th cell. But corresponding to this cell 5, this is the 5 cell from like this 1, 2, 3, 4, and then this is the 5th cell. So how do I figure this out? Not exactly not this 5th cell, this 6th cell actually over here because it's 0 based. So this A. How do I get this? It's a very simple mathematical idea. You can do something like this. 5 mod 4 comma 5 by 4 is actually I comma j. So this is 5 mod 4 is 1 and 1 comma, and this is 5 by 1, 1. 1 comma 1. Let's see. Yes, this is 1 comma 1 cell. Is this correct? This is correct. Yes, Ayush, you're absolutely right. Okay. This is 1 comma 1 cell. And now 1 comma 1 cell can be written as 1 into 4 plus 1. This is 5. So I can convert a vertical cell to its corresponding horizontal cell by this mathematical formula. Is this clear? So now I have solved almost everything. I know I'm going to first flatten H and V. Then I'm going to run KMP, figure out the places where the pattern occurs, mark all of them off. then convert the vertical into horizontal cells, and wherever finally the horizontal and vertical all cells are turned 1, I know that is a purple cell, my answer increases. Is the solution making sense now? There's a small point that I left out. How do you mark these cells? If you actually have ABA over here as a pattern that is marked off, how do you mark this? You can actually not mark this, as in you cannot go to A, B, and A, all these 3 values, and mark them by a tick. No, that is not possible. You will have to use something called as sweep line algorithm over here, which is going to look something like this. In this horizontal array, let's say this is hori array, in this you will turn on or place of I. I means this is the ith location where it finally starts the pattern as plus plus, and hori of I plus the length of the pattern minus minus. This is sweep line. So you will mark this as 1 and you will mark this as -1. And when you actually take a prefix sum on this sweep line, this will become 1, 1, 1, and then this will become 0. So automatically, you will be marking these 3 locations as the value 1, indicating that the pattern started from here and ended after that. Is this making sense, guys? There's 2-3 algorithms that are coming into picture. KMP, sweep line, and then of course your mathematics, general mathematics to convert verticals to horizontal cells. Is this clear? Any problem here? So what will this array finally look like? Let's actually see. First, the array will be made of something like this. Everything is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Then you will say, okay, I found the pattern from here to here. So this value is 1. And the value after this is -1. This value is, sorry, not this value. This value is 1. And the value after this, you can have one more extra index over here. This is -1. Then you take a prefix sum on this array. So this becomes 0, 0, 0, 0, 0, 0. Sorry, 0, 0, 0. And then you do 1, then 1, then 1, then again 1 plus 1, 1 plus minus 1, 0, then 0, 0, 0. And then this is 1, 1, 1, and then again 0. And this is the array you finally work on. And this array clearly indicates that the locations which actually have that letter, part of that pattern, has been turned on. So this is sweep line. Akshat, I think Akshat got it. Anybody who did not get this, let's move on to the code part first. And I think you will grasp from there. What are we doing? Okay. This is the code structure. Yes, this is called difference array. Correct. So first of all, I have the KMP logic over here. I'm not explaining KMP algorithm. This is directly picked from any good resource that you have. This KMP is going to return me a vector of all the locations, all the indexes where the pattern is starting in the text, which I pass. Let's come to the code. I have M as grid size, N as the column size. Capital L is the pattern size. Capital N is the overall size, N into M. Then the horizontal string H, capital H, horizontal string V, capital V. The difference array or the pre-sweep line array, diff of H, N plus 1 size, everything is 0. The horizontal vector N of 0, that is marking the prefix sum. The difference of V, difference array, and vertical N. Now first let's create the string H. How do I do that? I iterate horizontally. So left to right, push back grid of R of C in the H. This creates the horizontal string, flattened out. Then I create the vertical string, flattened out. Similarly, but I go from top to bottom. Then first I run the KMP match. So I call the KMP match algorithm, passing the H and the pattern, and all the places in the vector returned where pattern starts in this H string, I say that make plus plus of diff of H S and minus minus of diff of S plus L. L is the total size of the pattern. Simple. So this is the difference array. I do the same in difference array of V. So difference array of H is ready, difference array of V is ready. Now I have a current variable, that is the sum, that's the prefix sum variable. So I first run a loop calculating for H. Now in H, I'm simply calculating ith location. So I'll say, okay, add on the current sum, difference of H of I. If it is greater than 0, then horizontal of I will become 1. If it's not greater than 0, then it will become 0. So I'll be marking 0, 1, 0, 1 similarly in this array. Horizontal I is ready. Now I'll make current again equal to 0. I'll go in the loop again. 0 to capital N. Capital N, why? Because the size of this H and this V is actually N into M. Okay. Then I increment. But this time, if it's greater than 0, now I cannot write this directly because the way the cells were represented in horizontal is not the same way I represent in vertical. So I need to convert the vertical in representation of horizontal. That means first I calculate which row is it belonging to. That is I mod M. Which column is it belonging to? That is I by M. R into the number of rows plus C gives me the cell corresponding to the horizontals flattened cell. And that is turned on as 1. R into N plus C. So this is, I'm not sure what your name is. See, R is basically the compressed version of the location of row. C is the compressed in which column is it there. So R comma C is returned back. And then I convert it into the horizontal space. So let's say I was talking about this. Let's say I was talking about this cell over here. Okay. Let's say this cell B. So this is 2, 1. So I convert it into horizontal. That is 2 into 4 plus 1. That is 2 into 4. What is 2 into 4? 2 into 4 is 8 plus 1, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the 9th cell. That is why in the horizontal way, it would have been the 9th cell. So I convert it from the vertical way to the horizontal way by this formula. Is it making sense now? Did you understand this example with this B cell over here? Yes. The conversion is done. Now I have the answer variable. I go to each and every cell. If it's turned on in hor also and also in ver, that is horizontal and vertical, answer plus plus, return the answer finally. What is the time complexity finally? This creation of string is basically n into m. So this is like m into n. This is also n into m. Simple. Now the KMP match algorithm is going to run in n plus, like this is actually O of the n into n plus L. That is the size of the the size of the string I want to check in, and then the pattern's size, that is L. So this is pretty much not very large, and this is the same, n into m plus L. Now this is capital N, so this is again O of n into m, m into n, small, and this is the same thing. Then this is also the same thing. So I have finally received a time complexity that is n into m, which is in worst case 1000 into 1000, or not rather 1000 into 1000. N into m is only 10 power 5 order. So this is 10 power 5. And space complexity is also dependent on n into m. So this is again 10 power 5 order. Everything works out, and this is finally the problem. Okay. So I think this is a good place where we can stop. I hope you had no doubts along this process. If you have any more, if anybody watches this after, make sure you can comment. I'll make sure I can converse back with you and give you the explanation. Okay. Thank you so much for joining. How to get alumni discount? The alumni discount is actually only available for people who are part of the alumni, as in part of the previous batches. I'm not sure what your name is, but I can give one thing to you. I think the TLE CP31 discount is still running. So if you have solved any question in CP31, there is a special discount running in TLE CP31. Using the coupon code from there, you can actually get a 31% discount for this. This is again a very small running offer. We'll be closing this offer probably what is this morning. So you can maybe quickly buy the course right now, and that is going to be fine. Okay. Great. Thank you so much, everyone, for joining. I hope you like the problems. I took the fourth problem first and then the third due to special requests. But I guess all the 4 problems were very fun, very simple. And yeah, that's all from me. Thank you. Bye-bye. I'll be closing the stream. Thank you so much.